So this is an exercise related to rate of reaction. Exercise 2. It's one of the important topic in chemistry, like acids, alkalis, metals in extraction, organic chemistry, and this including rate of the reaction. You will find a complete question. So the first one, the doubts. Um, the first one is from page 2, question 1AB. B1 and B2. In experiment 3, student wanted the sodium thiosulfate to be a double concentration. If we want to increase the amount compared to experiment 2. So if we want to increase the amount of thiosulfate which was used we want a double concentration. So if we are using 20 cm cube in experiment 2, I want a double amount. So how much I should use to make it double? So what should be the amount if we want like to double concentration? So if it was originally in experiment 220, then we can use 40. You can use your mic or a chat to share the answer. So it will be 40. The volume of a hydrochloric acid, and then we have to complete this. The volume of the hydrochloric acid does not change in any experiment. Then how to get the volume of water used? As you can see, the total volume for each experiment is 60. 10 plus 10 plus 40, that is 60. 20 plus 10 plus 30, that's also 60. So if it is 40, 10, so how much distilled water should be used? That's also 10. So it will make 60. And then how much time it will take for the cross to disappear, because the rate of the reaction is inversely proportional to time interval. If we double the concentration, then the time will be half. So 20 become 40. So if it is double, what will happen to the time? The time will be half. So it was 28, it will change to 40. So experiment in B1, you have to complete to make the total volume. First, the double concentration for thiosulfate, and the sum should be 60. And the second part, if you increase the concentration or you double the concentration, the rate of the reaction will be like it increase. If the rate of reaction is doubled, it will take shorter time. Here volume is not affecting the rate, here amount is affecting, because like when you compare the proportion compared to total volume, we were only having 10 cm cube. Compared to total volume, we were having 20 cm cube, and compared to total volume, we have 40. So out of 60, 40 cm cube thiosulfate. Out of 60, 20 cm cube thiosulfate, and out of 60, 10 cm cube thiosulfate. So if this solution contains more thiosulfate, if greater volume of a thiosulfate in a mixture, it means there are more particles of thiosulfate. If there are more particles of thiosulfate, means they will react faster. As a result, the rate of a reaction will increase. And if the rate is double, what will happen to the time? The time will be half. So it's like the proportion of the solution, like we check the proportion of each solution in the total volume. In the total volume, amount of thiosulfate is more. That's how the rate of the reaction is affected. If more thiosulfate means more particles of thiosulfate, they react like more collisions between the particle. As a result, the reaction will be faster. Is it clear, this part, B1 and 2? Next is page 3. Page 3, question 2B. Page 3. A 5-mark question. The question is, a piece of magnesium ribbon is clean. The experiment was repeated using a clean magnesium ribbon instead of magnesium carbonate. The reaction is exothermic. Means the exothermic reaction, it give out energy. What will happen when the reaction is exothermic? The temperature of the mixture will increase. So rate of a reaction gradually increases over the first 2 minutes. What is the reason for that? Basically, what happened when the reaction happen or a reaction occur? Yeah, the temperature, because the reaction is exothermic, so temperature of the mixture increases. or there will be a temperature rise. As a result, yeah, if there's a like more temperature, as a result, what will happen? There will be more collisions, like or the particle energy increases. As the particle energy increases, they will have more, they will move faster, and they will have more collisions. They will collide often. And greater proportion of the particle, yeah, more kinetic energy, and more particles have energy more than activation. Or greater number of the particles with activation energy, more than activation energy. So greater proportion or number of the particles with activation energy. So the rate of the reaction of more collisions will be there. So the points we mentioned, 1 mark is for mentioning increase in temperature, 1 mark is for particles have more energy, 1 mark the particle collide often, more collisions are there, greater number of particles have energy more than activation, and particle move faster as well. Magnesium, what is the difference between magnesium ribbon and magnesium carbonate? Magnesium carbonate is a compound. Magnesium ribbon, like it consists of magnesium and it's only magnesium, the metal. So when metal react with an acid, it will give salt and hydrogen. If metal carbonate was there, if magnesium carbonate is there, react with hydrochloric acid, it will give salt, water, and carbon dioxide. So it will give magnesium chloride plus water, H2O plus carbon dioxide, CO2. The magnesium ribbon, normally it react with the surrounding oxygen and it will develop an oxide layer on the surface. That is a magnesium oxide. So first we clean it, as the magnesium is a reactive metal. So first we clean the magnesium surface by using a like a sandpaper. We remove that oxide layer and then we react. That's why they use the term a piece of magnesium ribbon was cleaned. What does it mean clean? It means we remove the oxide layer from the surface. No, it's not like it is just a question like where first we use magnesium carbonate and then we are using magnesium only. When magnesium carbonate was reacting with hydrochloric acid, the temperature of the mixture was not changing too much. But when magnesium react with hydrochloric acid, they mention it's an exothermic reaction, temperature is increasing. So explain what happened to the rate of the reaction. Previously, what happened when the magnesium carbonate was reacting, previous experiment when magnesium carbonate, the pieces of a magnesium carbonate were reacting with hydrochloric acid, the temperature of the mixture was not changing too much. So the temperature was not affecting the rate here. The main idea to set up this question to identify how the temperature affects the rate. When magnesium is used, then the reaction is exothermic, the temperature of the mixture increases. That's why the rate of the reaction also increases. But with magnesium carbonate, the temperature was not changing. So rate was not changing because of temperature. It was only maximum at the beginning. Is it clear, this one?
Yes, sir, clear.
So it's page 3, then page number 4, page 4, part B. The experiment was repeated using a same mass of a small pieces of marble. All other, if we use a small pieces, means the surface area increases. If a surface area increases, the rate of the reaction will also increase. But we did not change other parameters. So we have to draw a steeper, that's right, steeper gradient means greater angle, but the final amount should be same. Don't make like this, that is wrong. Why? Because it shows that first the amount increases and decreases. So what you have to do, it should be steeper, but the final amount should be same. And when you draw such graph, you should label, like example, this is a graph for part B. So this was page 3, page 4. Then page 7, 6B. It's page 7, part B. What happened to the rate of a reaction as a reaction proceed? This is a very common question. Rate of a reaction, because until unless if there is a change in temperature, then only rate increases. Otherwise, rate of the reaction always decreases. And why the rate of a reaction always decreases? Because in the beginning, we have more particle. Yeah, rate decreases with time. That is always 1 mark. Rate always decreases with time. And what is the reason for that? Because the concentration decrease or number of the particle decreases for the reactant. Few reactant particles will be there. Yeah. And then always the limiting reagent used up. So the points which we will include. First point is always the rate decreases with time. That is always the first point. For how the rate of a reaction changes with time. So this is always the case. Then what happened? The concentration decreases, so less particles, less collagen, less effective collagen, or they will have a slower rate. And one more, like, because as you can see, we use investigating rate of a reaction, but they did not specify in this question, they did not specify which one is a limiting reagent. So you cannot say that hydrochloric acid used up or calcium carbonate used up. You can just mention a limiting reagent used up. So first, the reaction is faster in the beginning. So rate decreases, concentration. So fewer, if in the question they mention hydrochloric acid is a limiting reagent, in that case, you can mention acid used up. Yeah, here actually it is mentioned. So excess. So you have to mention the acid used up. I did not read this part. You can say one of the reactant used up, but that is a very common term. According to question, as they mentioned in the question that acid is in the calcium carbonate is in excess, so you have to be specific that hydrochloric acid used up. So if you just say one of the reactant used up, that's a journal answer. But as in the question, they specify excess or a limiting, that time you should be in according to the question, you have to say which of the reagent used up. If you just say one reactant used up, is a journal answer. So this was page 7, and then we have page 9. Page number 9, question 6. So page number 9, 6, A2. Okay. Write a word equation. In this question, three factors which can influence the rate of a chemical reaction are their physical state, light, and the presence of catalyst. The first recorded explosion was in a flour mill was in Italy, 1785. It contained a carbohydrate. So when you burn a carbohydrate, what will be the product? Because carbohydrate contain carbon, hydrogen, oxygen. So if you burn a carbohydrate, or mainly like example, OH groups are also there. So if you write a word equation for the carbohydrate, so what will be the word equation for carbohydrate? If a compound contains carbon and hydrogen and you burn, it produces carbon dioxide and water. So if the carbohydrates are burned plus oxygen, why oxygen always? Because oxygen support combustion. So carbohydrate plus oxygen gives us carbon dioxide plus water. So whenever if a compound, like example, if the carbon is burned, what is the product? Word equation: carbon plus oxygen, carbon dioxide. If hydrogen is burned, hydrogen plus oxygen, water. But if carbohydrates are burned, which contain carbon and hydrogen, so the product will be salt. The product will be carbon dioxide and water. Both will be there. So the word equation is carbohydrate plus oxygen give carbon dioxide plus water. This was page 9 and then page 10, 7A, B, page 10. Yeah, why it catches fire or why it burn? Because this is a fine powder, so it will have a large surface area, can easily react or burn. That's why. So page 10. In this question, the only difference between the two experiments was the method used to hold down the magnesium. The first one we use a magnesium was held down by a copper, and the second one is magnesium is held down by a plastic. Like what we did in this experiment. In this experiment, we have an acid and we have a piece of magnesium. And that magnesium, piece of magnesium, we keep it at the bottom or a base by using a copper, or in another experiment, we kept it down by using a plastic. In which experiment did the magnesium react faster? So which experiment it react faster? You can see the first one, it's a steeper slope. So magnesium, which is held by copper one. So magnesium held by copper, this experiment, because much steeper slope. Suggest a reason why the experiment chosen had the faster rate. What might be a reason? If you have the same, yeah, the one which is held by the copper is faster. But what is the reason for that? The reason is, as you can see that both of the reactions, the amount of a product is same. So it means the copper is not the copper or a plastic are not the reactant, or they're not affecting the amount of a product. So it means in this experiment, copper is acting like a catalyst. Your copper act like a catalyst, and usually the transition elements catalyze the reaction. So that suggests a reason for that. The copper is actually a catalyst here. How we identify it's acting as a catalyst? Because it alters the rate of reaction but does not affect the amount of a product. Then experiment was repeated using 1 mole per dm cube propanoic acid instead of hydrochloric. Propanoic acid is a weak acid. We use the same amount but weak acid. How would the graph of propanoic acid differ? So how the graph of propanoic acid will be differ? First, it will be less steeper because weak acid reacts slowly as less steeper. And the second, how it will be same, the final product will be same. Why the final product is same? Because we are using same amount of both acid. So strong acid react faster, weak acid reacts slower. But the final product won't change if we use the same amount of the acids as we use the same concentration. So here the answer, how would the graph of propanoic acid different? So how it will be different? It will be like less steeper. And how would the graph will be same? It will give the same amount of hydrogen. Same amount of a gas given off, or same amount of hydrogen will be there. Then state two other factors which can alter the rate of reaction. So here what we can do, we can change the temperature. We can change the concentration, we can change the temperature. Any of them you can mention, like factor to investigate, you can mention concentration, and explanation, higher concentration, more particle, more collision. You can mention surface area of the metal as well. So high concentration, more particles, more collision. You can mention temperature as well. So you can even mention surface area of the metal, the magnesium. So if you mention temperature, high temperature, more particle collision, greater number of the particle have energy more than activation, or a particle will move faster or collide faster. If this was a gas reaction, we would when so the surface of a gas mode. You can mention or use another catalyst, another type of catalyst you can also mention. Or if you can mention for gases, normally pressure is there. So you can mention, yeah, if it was a gas, you can mention pressure. Pressure is more appropriate because catalyst is already mentioned in the question, so they don't award a mark for that. It's already there. So this was page 10. Next we have page 11, question 8. You can mention catalyst for any reaction, that's fine. It's not only for gas, you can mention catalyst, but because already this rate is affected by the catalyst, so if you write a catalyst as an answer, it's not acceptable as it's already there. So you have to write any other factor. If you mention more amount of a catalyst, yeah, it increases the rate of reaction. Increasing the amount of catalyst also alter or increase the rate of reaction. But for the previous question, the already the catalyst was mentioned, so they will not give the mark. So excess of a hydrochloric acid was poured and hydrogen gas was evolved. The volume was measured. We have metal A, B, and C. Identify the metal A, B, C and give a reason of your choice. First thing, we will write the reactivity because this question is actually related to the reactivity series. So we have potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, copper, mercury, silver, gold, and platinum. So the three metals which we have zinc, we have magnesium, and we have aluminium. First one, which is the most reactive metal here in this series? Magnesium is a more reactive. As we go down the group, the reactivity. So which reaction occur at a faster rate? So magnesium, aluminum, zinc. So
Magnesium.
magnesium should react faster. So which is reacting faster? Metal A is reacting faster because you can see the slope, it's much steeper. The angle is much greater with x-axis compared to B and C. So that's why the metal A is magnesium. And the reason is that it is more reactive. That is the first point. Then aluminum and zinc. Then which one is having a slope in the second number? Metal B or C?
Aluminium.
So which should be metal B? Metal B should be
aluminium.
Aluminium. And why? You can see for what you observe first the reaction was slow and then the reaction become fast. What why magnesium react in this manner compared to other metals? Why in the beginning the reaction was very slow and then suddenly the reaction became fast? The reason is that because a piece of aluminium is having an oxide layer. So whenever you have aluminium, if you have a piece of aluminium, it has a protective oxide layer which does not allow to react initially, or the reaction will be slow. So whenever you have a piece of aluminium, it will have an oxide layer which is aluminium oxide. So metal B is aluminium oxide, aluminium. And why we select aluminium? Because in the beginning it reacts slower at the start. And what is the reason for that? Due to oxide layer. And then when the layer is removed, so once the layer of the aluminum oxide is removed, then like first aluminum oxide was reacting with acid, that's why the reaction was slower. But once this layer is removed, then the aluminum start to react with an acid and the reaction will suddenly increase. Why we did not select metal B as magnesium? Because the one which is steeper, we don't check the final amounts. What we check the initial slope. So when you check the initial slope of these metals, so when you check the slope, which is the fast or the fastest, so A is the fastest because A is having the maximum initial angle. Why metal B is magnesium? Because in the beginning it is slower and then it increases. So why metal B is aluminium? Because in the beginning it is slower and that it increase and due to oxide layer. That's how we identify metal B. Metal B does not have slope more than metal A. Amount is more, but not the slope. Slope means angle with x-axis. So when you check the slope of metal A is much steeper than B. Like this is the slope of A. When you check the slope of B, the B is having a smaller slope. Like this part, this slope is small. And for C, this is the slope. So A is having the highest slope, then B is there, and then C. Now, even when you check the final slopes, how to identify, like example, if I remove this part and I want to measure the angles, because this part is when aluminum oxide layer is removed. When I check the angle for A, I will check the angle with x-axis. This is for A. For B, when I check, because for first part it was aluminum oxide was reacting with acid, but then aluminum is reacting. So this is the angle for B. And when you check the angle for C, so this is the angle for C. So when you check angle of A, B, and C, so A angle is more than B, and B angle is more than C. We are not talking about amount of the product. We are checking the slopes, the angle with the x-axis. So A is much steeper. That's why A is magnesium. B is the second number. That's why it's aluminum. And the least reactive in this series, that is zinc. So zinc is less reactive in this combination. That's why C is zinc. So this was page 11. Next is page 12, part B. Page number 12. A2I. Explain the trend of a reaction that you describe. Like how the rate of a, does the rate at time T1, T2, and T3 differ? And it's of 2 marks. So how this rate of a reaction, yeah, T1 is the highest, then T2 it is decreasing, and T3, after T3 the reaction has actually stopped. So T2 is less than T1 and T3 is actually the reaction is, so T1 it is fastest, T2 is slow down and T3 is stop. That's right. The next part, explain the trend of like basically why it happened like this. So what is the reason for that? Because in the beginning, why T1 is greater than T2? Because in the beginning we have more particles, so higher concentration. But as the concentration of the reactant decrease, less collagen, a few particles, so rate will also decrease. Yes, you can mention in terms of angle as well. So the points here, T1 reaction is the fastest, then T2 slow down, and then T3 the reaction stops. So this is always the trend. Whenever a chemical reaction occur in the beginning, it is always faster. Here, as it's a it's a decomposition reaction, so you don't have reactants. You have only one reactant, that is a hydrogen peroxide. So you cannot say like a limiting reagent used up or one of the reactant used up. Why? Because this reaction only involve one reactant. So you cannot suppose it's only a decomposition of a hydrogen peroxide which give off water and oxygen. So as the number concentration decreases, so few particles will be there, less collisions, smaller rate, that you can mention. And eventually what happened, all of the hydrogen peroxide, H2O2 is hydrogen peroxide. So all of the hydrogen peroxide used up, the reaction will stop. So this was page 12. Here the reaction stopped because hydrogen peroxide used up. Describe how would you show that the catalyst manganese 4 oxide was not used up. So how to know that, like we use a manganese 4 oxide as a catalyst. So what we will do, if a substance is a catalyst, first we measure its like a substance to be a catalyst, it should alter the rate of the reaction without chemically consume. So we'll filter, then we dry and we wait with the catalyst. And we compare the mass before and after. Because if a substance is a catalyst, its mass will not change. So we will filter one mark, we will filter from the mixture and then we will dry and then we'll wait. And we'll compare the mass at the start and the end of reaction. If the mass does not change and it alter the rate of reaction, so the substance is catalyst. So the question is, how could you show that the catalyst manganese 4 oxide was not used up? So how we can show it's not used up? We'll filter and then we dry and we wait again and then we compare the mass at the beginning and the after. If the mass does not change, it means the substance is a catalyst. Is it clear, this one?
Yes, sir. Clear.